Welcome to the House That STEM Built, a regular series where we will explore the science, technology, engineering, and math that goes into the design and construction of this family home. This is the House That STEM Built.
In today's episode, we will investigate what are known as simple machines. We will look at where they show up during and after the construction of a family home.
There are 6 types of simple machines: the lever, the pulley, the wheel and axle, the inclined plane, the wedge, and the screw.
This video will address the Grade 5 Science General Curriculum Outcome, GCO2. Students will develop an understanding of the nature of science and technology, of the relationships between science and technology, and of the social and environmental contexts of science and technology. This video also contains some higher-level concepts and complex examples, making it appropriate for studies in science and technology at the middle and high school levels.
Simple machines can be found throughout our daily lives. You don't have to look far to see all kinds of simple machines at work around you, making the tasks you do easier.
Let's take a closer look at the 6 simple machines.
First on our list, the lever. A lever consists of a solid arm that rotates around a point. That point is called the fulcrum. This simple machine closely resembles a seesaw. The lever is useful because it generates what is called mechanical advantage.
Let's say you decide to sit on one end of this lever, while some of your friends put a large weight on the other end. If you weigh 45 kilograms, but the weight on the other end weighs 450 kilograms, there's no way you'll be able to move the weight. This is because the fulcrum is in the middle of the lever arm. If the fulcrum is moved to be much closer to the heavier weight, you can move it, even though it weighs 10 times as much as you do.
In this case, mechanical advantage is gained because we are making a trade. The distance this side of the lever has to move is much greater than if the fulcrum was in the middle of the lever. But not nearly as much weight or downward force is needed.
This is why levers are very useful. By increasing the length of one side of the lever, you increase the resulting force exerted on the other side of it.
Next, let's talk about the pulley. Pulleys consist of a rope or cable that moves over a wheel. The main purpose of a pulley is to redirect effort.
If you wanted to pick up a weight from the ground, you would have to pull up on it. Believe it or not, this isn't a very efficient way to pick things up. However, if you attach one end of a rope to the weight and feed the other end through a pulley, you are able to redirect the force needed to lift up the weight. The weight needs to be pulled up to be lifted off the ground, but feeding the rope through a pulley allows you to pull down instead. This allows you to lean into pulling the rope, which uses your whole body weight better.
In this situation, though, there is no mechanical advantage gained. To gain mechanical advantage, you need to add another pulley and some more rope. By attaching the rope to a fixed point here, feeding it through the new pulley that is attached to the weight, and feeding it back through the first pulley, we have increased the amount of rope that is supporting the weight as we pull.
This part of the rope supports half of the weight, and this part of the rope supports the other half. Since we are only pulling on this part of the rope, the amount of effort needed to lift the weight is split in half.
It doesn't stop there, though. We can keep adding more and more pulleys to this system, further reducing the amount of effort needed to lift the weight. It's easy to see how useful the pulley can be, especially back before the invention of large machines that help us lift and pull heavy objects.
However, this mechanical advantage comes with a trade-off similar to that of the lever. The more mechanical advantage you gain by adding pulleys and rope to the system, the more rope you need to pull to move the object the same distance.
Third on our list of simple machines is the wheel and axle. While you may be familiar with the wheel and axle from vehicles like cars, wagons, and trailers, this is not necessarily the context that the concept of simple machines applies to.
Gaining mechanical advantage with the wheel and axle is very similar to the lever. In fact, on a wheel with handles like this one, each handle acts as its own lever. When you apply a force to turn the wheel, the axle turns with it. However, Since the axle has a much smaller circumference than the wheel, the distance the axle travels is much smaller than that of the wheel.
Let's trace out the path of the wheel and the path of the axle. If we unravel these circles, we can see just how much shorter of a distance the axle travels. This is very similar to the lever. To gain mechanical advantage, we are trading distance for effort. By moving a wheel with a large circumference, we can lift something very heavy by attaching it to an axle with a much smaller circumference.
The bigger the difference in size between the wheel and the axle, the more mechanical advantage you will gain. This technique was often used to lift a heavy bucket full of water out of a deep well using a rope.
The fourth simple machine is the inclined plane, though it is more commonly known as a ramp. It is most often used to help carry a weight up a vertical distance or to help a vehicle get over an obstacle.
If you wanted to lift a heavy box onto a platform, walking up to the platform would be relatively easy. But once you reach the platform, you would have to put in much more effort to get up onto it.
However, if you were using an inclined plane, you would be putting in a little bit more effort than you would if you were walking on flat ground, but spreading that effort out over the length of the inclined plane would allow you to get onto the platform without the need for a big increase in effort at the end. The less steep you can make an inclined plane, the easier it will be to walk across it.
Next on our list is the wedge. Triangular in shape, wedges are often used to split things apart, but can also be used to hold objects in place. A common example of a wedge used for splitting things apart would be an axe, while a common example of a wedge used for holding objects in place would be a doorstop.
The main purpose of the wedge is to redirect force from the back of the wedge, being its short edge, to its two long edges. Let's take a look at the axe head. If you put in the effort to drive the axe into a piece of wood, that force is redirected in these directions, perpendicular to the long edges.
If we make this axe head shorter, look at the direction of the redirected force. It is now pointing almost directly towards the wood. That's not what we want. We want to split the piece of wood, not push it into the ground.
You can see that the longer we make the axe head, in other words, the sharper we make the axe head, the force gets closer and closer to being completely perpendicular to the force we are putting in. This is good because we want to split the wood apart in this direction. But as you can see, to get mechanical advantage, we are trading distance for effort because we have to drive a long axe head further into a piece of wood than we would with a short axe head.
Last but not least, let's talk about the screw. Screws are useful because they convert rotation into linear motion, or motion along a straight line. They are made up of an inclined plane, called the threads, that wrap around a cylinder in the center, called the shaft.
Since the screw has an inclined plane that is part of it, the same principles apply for gaining mechanical advantage. The less steep the inclined plane is, the closer together the threads become, and the more mechanical advantage is gained. This means that you will have to rotate the screw more times to travel the same distance, but it will be able to put out a much greater effort.
To further increase mechanical advantage, you could also apply the principles of the wheel and axle to increase the size of the head of the screw you are turning, making it even easier to turn.
The screws on a construction site don't look like this though. They have a sharp point at the end. This sharp point acts as a wedge and allows the screw to drive itself into whatever material the construction worker is working with.
Let's take what we've learned and apply it to the construction of a house.
The 6 machines we just learned about may seem simple, but when we look at machines you would find on a construction site, it's hard to say that any of these machines look simple at all.
Let's see if we can identify simple machines at work in these more complex-looking machines.
Let's start by looking at a pry bar. This tool is a long piece of metal with a bend at the end of it, most often used for removing nails from wood. Pry bars are a great example of a lever.
We can see that the pry bar rotates around this point, making it the fulcrum. We can also see the arms on either side of the fulcrum are different lengths, which means if we exert a force on the long side, we will gain mechanical advantage. When the fulcrum is between the effort and the load, it is called a first-class lever.
Next, let's explore this wheelbarrow. Do you know what category of simple machine is at work here?
We can see that the whole wheelbarrow rotates around one point. The the wheel, making it the fulcrum. The bucket and the handles act as an arm, making the wheelbarrow a lever. This is what's known as a second-class lever, because the load is between the effort and the fulcrum, instead of the fulcrum being in the middle like we saw previously.
With a second-class lever, we know that the load will always be closer to the fulcrum than the effort, so we know we will always have mechanical advantage, making the wheelbarrow a very useful tool to move heavy things around.
Up next is this crane. Cranes like this are used to lift heavy objects that need to go very high. They're often used to lift pre-built trusses, like the ones you see here, to where they attach onto the top of a building. This crane is using a combination of many pulleys to gain mechanical advantage while lifting heavy objects.
Let's go back to our diagram of using pulleys to gain mechanical advantage. We will rearrange the locations of these pulleys soon, so let's number them to keep track of where they are.
Point number 1 is where the effort is being applied.
Point number 2 is the pulley that redirects the force, allowing us to pull down instead of up.
Point number 3 is the pulley that introduces mechanical advantage, splitting the weight between these two sections of rope.
Point number 4 is where the rope is attached to a fixed point, supporting half of the weight below.
If we add one more pulley to redirect the force, the final result is what goes into the crane.
The effort is being applied to a cable by a winch at point number 1. That effort is redirected by the pulley at point number 2 down to point number 3, where the load is located. We will have two sections of cable supporting the load. The effort is then redirected up towards this new pulley, which redirects the effort again towards the fixed point at point number 4.
This extra pulley between points 3 and 4 also allows the crane to move the load freely back and forth to get it where it needs to go.
Next, let's look at this mini excavator that's drilling the deck post supports. Two simple machines are being used here.
At the end of this deck post support, we can see that it looks like a screw. The mini excavator has a drill attachment that rotates the post support, which makes it move straight down into the ground.
The other simple machine at work is the one that is helping to push the post down. The arm on the mini excavator is acting as a lever. Here's the fulcrum. Here is where the mini excavator is applying the effort. And here is the load, or resistance. It is called resistance because the post is resisting being pushed downwards into the ground.
Because the effort is between the fulcrum and the resistance, this makes it a third-class lever. In this case, since the effort will always be closer to the fulcrum than the resistance, a third-class lever will never have mechanical advantage.
However, that is not necessarily a bad thing. Remember that mechanical advantage is a trade between effort and distance. If we have a powerful machine that is strong enough to supply the extra effort, like this one, the extra distance that the end of the lever travels is more useful to us than reducing the effort needed to move it. This helps to get jobs done faster on a construction site.
The last machine we will explore is the front loader. This machine is a large tractor with an arm and a bucket attached to the end.
First, we can easily identify the arm as a third-class lever, just like the mini excavator.
The next simple machine we can identify is attached to the end of the arm. This bucket has a sharp edge on the bottom. This edge resembles an inclined plane or a wedge. This makes it easier to scoop things up off the ground, like this large rock.
The front loader is applying effort horizontally. The wedge at the end of the bucket splits that effort into two directions, each perpendicular to the surfaces of this edge of the bucket. This direction is the one we are interested in. It tells us that the rock is being lifted up off the ground.
Finally, the last simple machine in use here is the wheel and axle. Like we explored before, mechanical advantage is gained on an axle of small circumference when we apply an effort to turn a wheel with a larger circumference. This is because we are trading distance moved for effort applied. However, as we discovered with the third-class lever on the mini excavator, when we have powerful machines that can supply that extra force, the extra distance gained is where the real advantage is.
This is true for the massive wheels on the front loader. This machine is very powerful, so it can put in the extra effort to turn the axle a shorter distance. This turns these large wheels which cover a larger distance, allowing the front loader to travel back and forth more quickly than if its wheels had a smaller circumference.
In this video, we learned about each of the 6 simple machines and how they use mechanical advantage to make our lives easier.
We also learned how they can be combined in many ways to create complex machines that do things we wouldn't be able to do on our own.
Where are some other areas on the construction site that simple machines are used?